So I'll introduce Rubaiat Habib, who is a senior research scientist, illustrator, and designer at Autodesk Research. But he's also an artist. He's actually mainly an artist. Well, he's working in design and development on new forms of art and animation and communication tools for end users, facilitating new ways of thinking and communication, and at the same time creating some playful experience. If you go on his website, you can see that his projects are actually very playful. And I should also say one thing that struck me, the fact that he did his PhD in Singapore, I think? Yes. And he did his dissertation in the form of comics, which is something that I deeply admire because I would have never been able to do it here in Canada. So I really admire you. So, and his work has been the recipient of many awards, and just to mention two of his research projects, Draco and Sun Canvas, have received some prestigious awards from ACM and SHE. And I hope that I'm going to see something from them tonight, because this really inspired my rationale for giving the title to this event. So no pressure, eh? So, thanks.
Thank you very much for the introduction, Roberta, and thank you very much to all of you for coming here and all the organizers for organizing this. I really enjoyed the earlier two talks. I'm a senior research scientist in Autodesk. For those of you who don't know Autodesk is a software company who makes AutoCAD, mainly softwares for manufacturing, 3D modeling, and engineering like AutoCAD, Rubaiat, and even softwares for film industry like Autodesk Maya and Sketchbook. And even though my background is in computer science, I do illustrations, but this is more like a hobby for me. And as you say, I have done my PhD thesis in the form of comics, as an attempt to communicate scientific ideas with storytelling and art. And I was not sure whether the school would accept it, but I'm really glad that they accepted it. And so, anyway. So my research interest lies in the design and development of new forms of communication tools, digital art tools, and presentation tools with playful experience. And the time is just about right, because the ubiquity of tablets and mobile devices creates enormous opportunities for us designers to create these kinds of tools where people can think creatively, be creative, and create contents. So today I will talk a little bit about textures in the context of art, animations, and illustrations. And I will do some demos of some of the softwares that I've developed over the last couple of years. So the first project I did was Vignette. This was pretty much inspired by this drawing. I did this drawing like almost 10 years ago, back in 2005. And as you can see, it's my village. And it was done with a pen and in a piece of like A4 size paper. And it took me the whole day. It took me almost 7 hours to do so. You see, this picture is full of textures, right? There is all these different types of textures. Textures for the background, textures for the trees, and textures for the walls. And if you take a closely look at it, you see that there's lots of repetitions. But the thing is, like, textures are very expressive. I mean, with a few strokes, a texture is a group of strokes, right? With few strokes, you can convey material, lighting, and emotion. I mean, they're very expressive. Pen and ink illustrations contains this wide range of artistic styles. As Arthur Goodwill says, that pen and ink illustration is like handwriting. No two artists have the same drawing styles. Everybody have their own distinct styles. That's why textures are so expressive. So the fact that manual pen and ink illustration is so tedious, I started to thinking, how can we make it much more easier? But you have these computer tools like illustrators and other types of software tools to create patterns, but those patterns have that stiff mechanical look. in contrast to this hand-drawn organic look, right? So how could we develop a software that has this organic hand-drawn look, but at the same time speeds up the process? So this is the first project I'm going to talk is Vignette. It's a sketching tool for pen and ink illustration, and this was done when I was a visiting researcher in Japan Science and Technology Agency in collaboration with Takeo, Shindong, and Richard. So okay, so let me just bring it this way. Okay. And I think I need to duplicate my screen. Okay. So imagine this thing. So this is the software, right? Say I want to add some textures and drawings into it. I will start by drawing some civets. So I sketch some example civets. And then create a texture. And then I continue adding texture. Right? And then I want to add a flock of fish. So once again, I draw. This case I did. So once again, I draw some example fishes. And then create a texture. So you see, it like the resulting illustrations has this organic look, and everything is generated from your hand drawing textures. Imagine you would have done the same things in Illustrator. You have to draw 3 fishes, you have to copy that layer and paste it. But in this case, it's much more fluid, and the resulting illustrations have that organic hand drawn looking, right? So I will not like illustrate all the other features, but there are many other different types of filling techniques. So this is one type of filling techniques, but there are other types of filling techniques. Now, after this project, I started, these are some of the example drawings created by the participants. So this is the participant who was testing our software, and he is the first time, he has never used the software. And he created this drawing in less than 5 minutes. It's a crowd and fireworks. And this is also by a first-time user. And he created this illustration in less than 19 minutes. But you see, there's lots of repetitions, but it's not obvious there is a software using it. The resulting illustrations has this hand-drawn organic look, but still at the same time, it significantly makes the process faster. Now, as a growing adult and animation fanatic, I always wanted to bring life into my drawings. And when I was in college, I started looking at animation tools, but it felt like it's so different from the world of drawings. There is this world of illustrations where you use Illustrator, Photoshop, Sketchbook, and then there is a whole different world of animation where you have like Flash, Maya, and other kinds of complex 2D animation tools. But like, these two worlds shouldn't be different. These two worlds should be closer. So I started thinking like, can animation be as easy as drawing? Can we bring these two worlds closer so that you can make animation as easy as drawing? So when I first came to Autodesk, I started working on this project named Project Draco. One second. Duplicate. Okay. And so the motivation of the project is to bring life into drawing. So here are some of the examples. You see, it's the same tool, but there is no timeline into it. It's the same tool, animation, that helps you to create animated drawings without adding the complexities of timeline and all these animation parameters. I will do some demos, you can see. So in this case, we still have the textures, but the difference is that these are kinetic textures. We are moving from still textures to kinetic textures. Here are some other example. So in this case, what happens is that a kinetic textures consist groups of similar looking strokes, and they are moving. So as you can see, if you look around us, you will see a wide range of phenomena that consist of groups of strokes like steam, snowfall, and then even from very natural to very artistic ones like fan blowing of air. There are traditional tools like Flash and Maya and all those After Effects, where you could create these kinds of animations, but they're extremely tedious to do. It's extremely difficult to learn and use those tools to create these kinds of effects. This is the tool. I'm using the tool to do the presentation now. So this is actually, I'm using the tool for doing the presentation. Now, we wanted to design something that is general, where you can create a wide range of animation effects using a simplified animation framework, a tool that gives enough control so that you can create very fine, intricate animation effects, and a tool that relies on users' intuitive sense of time and space, so that you don't have to rely on all those parameters and timelines. So once again, we are back to this demo. In this case, I will create an animated drawing. So you see there is no timeline. So once again, I will start by sketching some example civets. And then I create a texture. But now I want to animate it. So I can simply animate the whole texture by just adding a keyframe. Starts animating. Right? I can change the keyframe. I can make it. So at any point of time, you can move the texture. Now, if you look at many of the natural phenomena consisting groups of stroke, they have these subtle variations. There is like natural variations. So what I did so far is that I have animated the whole texture, but there is no natural variations within the animation of individual leaves, right? So let's animate the individual leaves now. So I just record a rotation motion. So you have these motion controls over multiple scales. You can animate the whole texture, and then you can animate the individual strokes. That gives you a lot of expressiveness. I can make it more subtle, right? And then I select this tool, and I can also similarly animate it. It's very easy, right? Now I want some bubbles to come out from the diver. So I sketch some bubbles. Now I want the bubbles to move along this trajectory. It's as easy as this. So you see, once again, there is no timeline, and I can make the bubbles to spread, right? And sometimes we want the bubbles to grow in size gradually, right, as they are moving. So you can do it simply by drawing a motion profile. You can say that the scale of the bubble should grow in size. It's too much, so I can or I can do vice versa. I can say that the opposite should happen. Or I can do something like this. Okay. And then similarly, I can add a flock of fish. So I can once again draw some example fishes. But in this case, I want them to move, right? So I can just specify their motion path. You should move over here. And then I can say, I can increase the emitter. And I can add more motion lines. I can also change their scale, like before. As they are moving, I can, right? And then I can also say that when the fishes starts, they have a higher velocity and then they slow down. So I can say that I can do that by doing this. You see? Now they're coming out faster and then slowing down. I can make it a bit more dynamic. So without this tool, it would have been taken a whole day to create an animation like this. But it took me just 5 minutes to create this thing. And it's animating. It's not only just textures. These kinetic textures, textures that move. And it brings life to your drawings. So you see, so the design philosophy of this tool is that this tool is strictly by example. I mean, like, unlike many other animation tools, there is no complicated physics engine into it. Everything is driven by the user-provided samples and input. And the fact that you have motion scales over multiple scales gives you a lot of expressiveness. So you can create really fine, intricate animation effects. And it relies on users' intuitive sense of time and space. We are combining the process of sketching and animation. It feels like you are sketching the animations, right? So here are some additional results. This is one of my co-author, Toby Grossman. It's Happy Holiday. And this is Toronto in the summer. So Autodesk is currently looking into ways to make this technology available to mass users. Now, after this, we wanted to see, like, how can we push this even further? We have looked into animated drawings, but what if we can make these drawings interactive, right? As you interact with it, the drawing changes. So that is the follow-up project named Kitty. So we started looking, how can we make drawings interactive? For instance, as I swipe along the tree, leaf starts falling, right? Now, in this example, if I swipe, the velocity of the wind increases, right? Now, if I swipe from top to bottom, it starts raining. If I swipe even more, it rains more, and at some point you can see thunderstorms in the scene. Now you see what happens, like when I am changing the velocity of the wind, there are other effects in the scene as well. The windmill is rotating slower, and the leaves are moving slower. So there is a link and relationship between all these visual elements, right? So these are dynamic illustrations. A dynamic illustration responds to user interactions. And as viewer, it helps us to understand the cause and effect. If I change these things, what are the effects that is having into the scene? So dynamic pictures will someday become the primary medium of visual art and exploration. So the key property of dynamic pictures is that they're driven by data and parameters. Parameters mean that as I interact with the drawing, the parameters changes. The parameters can be opacity, it can be rotation, it can be anything. So what happens is that when I'm interacting with the drawing, some parameter is changing, and that parameter change is triggering the change of other parameters. So how can I create such kind of thing? So I will do a demo with this one. So I have an animated drawings, but what I want to do is that I want to make it interactive. When I interact with it, something will happen, but there is no interaction at this moment. So imagine this scene. In the interaction mode, I want the egg to move along this particular trajectory. Now, when I switch to interaction, the egg moves along this trajectory, right? And the cat is hungry, so he wants the egg. So now, there is a splash, but we want the splash to happen only when the egg hits the surface of the pot. So let's switch to the graph mode, and you can see all the visual elements as nodes. Now I want to create a relationship from the egg to the splash. That means that the splash is dependent upon the egg and dependent upon the translation of the egg. So the emission of the splash is dependent upon the translation of the egg. So I created a relationship. And I said that the emission should be 0 up until this point. When the egg is near the pot, there should be a splash, and then it becomes 0 again. Now see what happens. Now there is there is no splash, right? But as the egg hits the surface, you see, when the egg is here, only the splash happens. Now the cat should be disappointed, right? We can also author the disappointment. We can say that the cat's eye should follow the trajectory of the eggs, and then when the egg hits the surface of the soup, the scale of the mouth should change, becomes 0, and then it also stops waving its hand. So the velocity should become 0 as well, right? It's very, very simple, very logical. So let's see what happens. The cat is disappointed. So it's very simple, very easy to use, but it's extremely expressive as well. So here is one drawing. This is an animated drawing, again with Draco. And I did this drawing like a couple of months ago. As you can see that I've been in Toronto for 1.5 years. My wife loves winter, but as you can see, I don't. So what I want to do is that I have this weather data file, and this is actually this weather Excel file has the weather forecast of a particular week. So I want to convert this animated drawing into a data-driven infographics that portrays the weather of the particular week. So I load this weather file, and you can see all the attributes here. So now I say that there is a relationship from the snowfall to the calendar, and the function is generated from the snow. That means that in the beginning of the week there is not much snow, but like in Friday there is a lot of snow in the weekend. Now once again I create another relationship from this to this and derive the relationship from the wind data. So this is the wind, right? Yes. And finally, if there is more wind, there should be more jittering, like which is the terminal velocity. Okay, so these are the relationships. All right. So now see what's happened. Now see what happens. So in the beginning of the week, there's no snow, a little bit of wind. In the middle of the week, it's snowy, but it's not that windy. But in the weekend, it's snowy and it's also lots of wind. So just in a matter of minutes, I converted this animated drawing into a data-driven infographics. And here is another example. This is done by one of my co-authors, one of my favorite ones. So this is illustrating a recipe for a juice. So step 1, turn on this one, put the banana, put the orange, and drink the juice and be awesome. So my co-author Toby Grossman have never done drawing or animation, but with this software he did it like in less than 15 minutes. And unfortunately it's clipped, my screen is clipped for the resolution, but imagine this comic strip. It shows how the scene changes as time progresses, but with dynamic illustrations you can convert it into a single drawing. So as I interact with it, see how the scene changes. I can interact even with tree, with the plant, and see how the scene changes. And this is the underlying graph. This is the graph. So the fact that this tool uses kinetic textures as building blocks makes this tool very expressive, and you can create a wide range of contents with it. And this is a technical illustration showing how a mechanical bell operates. So in this case, when the button is pressed, electricity starts to flow, which charges the magnet. This eventually attracts the iron armature, causing the bell to ring. And this is the underlying graph. So it's not an animation tool or drawing tool. It becomes a powerful tool for presentation, for communication. So as a teacher and educator, you can create technical illustrations. As a designer, you can create data-driven infographics or UI mockups. As a researcher, you can demonstrate how your software or hardware system works. or you can do your presentation just like me. And here are some of my collaborators. Yeah. So this is Kitty. So it started from texture illustrations to kinetic textures and then to dynamic pictures. So before ending, I'd like to show one more project that I did. Since it also relates to texture. So are you familiar with sand art or sand painting? Did you see performance art sand and artists telling a story with sand? So this is the project. This is a project I did when I was in my PhD. Unfortunately, I don't have a video of original sand art, but I have the video of my tool. So what we did is that we made a hardware consisting of acrylic plastic, and there was a projector just behind the plastic. So it's just like a tabletop display, but it's custom made. And we did develop this software along with the hardware to create sand animation-like images. So you see, these are some of the features. It's a digital screen, and it's a virtual sand, of course. And you have all these features where you can actually redo, undo, and create real sand animation-like images. And the system has very sophisticated real-time sand rendering. It's a lot of computation, but we did a lot of optimizations to make the sand really real. Like if you push all the sands here, it will gradually erode. So it had all this physics there. And you can also record gestures and play it back, like here, right? I recorded a gesture and I played it back in different time and different space. So it has it's inspired by physical art medium, but it has all these digital affordances. Like I recorded that gestures and played it back in different space and different time. And sometimes you can also use these sand textures on the top of a video to create mixed media performance. So here is one of my drawings with sand canvas. So in this case, you see I'm drawing with sand canvas to create sand animation-like drawings, but also I have recorded some gestures beforehand. So as I'm drawing, I'm playing back those gestures. It feels like many gestures are working together at the same time in parallel. So it suddenly changes the scene, right? And these are all virtual sand. It's just a touch screen. There is no real sand into it. So one of the beauty of this hardware is that unlike iPad or any other touch screens, it captures the whole hand. So in most of the capacitive touch screens in iPad, it captures only the fingertips, only the points. But here, with our hardware, you could do actually piling sands like this because it's captured the whole hand. It models the whole 3D hand. So it has a greater bandwidth. And we saw the sand artist doing all types of gestures. Like in iPad, you do only this or this, right? But in our things, the users were doing gestures like this. They were using all parts of their hand. They were using gestures like this, gestures like this, gestures like this. So it's much more expressive language to interact with computers. And yeah, so I make digital art tools, but I seek inspiration from traditional art practices, from the rich history and aesthetics of traditional art. And I believe technology has a lot to learn from all this rich history and inspired. And to me, a shining example is Pixar, where artists and scientists work together to create an entirely new medium. So that's a shining example where the intersection of art and science can create magical experience. So thank you very much for listening.